Okay, this is instrumentation lab 2, final control lab 4. Those of you that have been in we got a chance to come out here and work on this one. This is the analog pressure transmitter now. So compare this to our I to P transducer, which is receiving a signal from the PLC. This transmitter is actually sending a signal to the PLC. So in this particular case, once we wire our PLC up, we have to bring the signal from the pressure transmitter into the analog input card to set it up and get it, and so it receives its signal. Now this particular case here, if you look, we have a V/I 0 negative, we have a V plus, and we have an I plus. This is a 4 to 20 milliamp output signal from that transmitter, so we're going to connect our power supply plus to here, or I mean our signal plus from here, and our negative will go here. Now remember, the power supply dictates, so you're going to have to locate which one of these two terminals is plus, and then connect that plus, break the signal here. We'll have to break the states block there. Put the plus wire from here to the plus here. Then the minus is going to go to the other side, the upstream side, which is actually ends up going to the plus on the transmitter, if this is the plus. Now how would you tell which one's plus and which one's minus? Here's your source power coming in. We know that this should be plus. So if we look at it right, if you look at this, this is going to be our plus in this particular case. That may not always be the case. I may swap it around. But the easiest way to do that is to take your voltmeter, put it on DC voltage, and put your terminals there and there. If you put your plus here and your minus there, and it reads negative voltage, then you've got your polarity backwards. This would be the plus, this would be the minus. If you put your plus here and the minus there and it reads positive 24 volts, then you've got it right. This is plus, this is minus. Always remember that the power supply dictates what connects to. But first of all, be sure you isolate the transmitter. This actually has the stinger and all in it. None of that, all that stinger, all that information, all this up here will be gone, remember. I'll have the stinger out, it'll be in here, plugged off, it will be in process. The system will be in process. So when you come up, you have to isolate it from the process, bleed it, you can hear bleed, then connect up your pressure source from your regulator. Then you can go to the process of raising and lowering the pressure. Now again, this is something that I want everybody to be able to do eventually, but because we're so limited on time with these particular labs for this particular semester, I'm not going to require you to change the pressure that's set on it. I will calibrate it and have it set up to where it has a 4 milliamp signal at a certain pressure and a 20 milliamp signal at another pressure. I'll give you those values, or no, actually I'd rather you find those pressures out. It's real easy. All you have to do is find the low pressure and the high pressure for it, simply by putting a multimeter on there. Whenever you get a pressure that's reading 4 milliamps output, that's your low range value. When you get a pressure that's reading 20 milliamps output out of the milliamp meter, that's your upper range value. Then you're going to connect those again, as I said, into the analog input card. Also notice one thing here, this one's not working yet because it hadn't been powered, so you need to be sure, as always, to remember to power your PLC. Plus 24 volt DC, minus 24 volt DC. But again, the analog input card signal is going to come in. It's going to show up in your PLC, in your PC, just as it did in the I to P, but it will be in the input data file for the analog signal, I:1.0. If that's what you put it on as channel 0, we got 4 channels here, so if you put it on channel 0, I:1.0 is where that value is going to show up. Quick note there: if you show a value that does not change with a rise in pressure, then there's very good chance that you've got the polarity backwards on there, because a lot of times if polarity is reversed on any one of these wires, there'll be a number show up there, but it will not change. So if that happens, be sure to look for your polarity changes. And remember, how we did. As a matter of fact, we did this project. You should have a wiring diagram for this project that we did in the project file for instrumentation. And that's all I'm asking you to do with instrumentation lab 2, final control lab 4. Just wire in the pressure switch. I'm pretty sure it was final control that I did this project for you, or had and showed you how to do it. The only thing that might be a little different is the fact that we've got the states blocks in there as opposed to terminal block before. Okay. Next is lab 7, instrumentation lab 7. The main thing I'm looking for here is that you can hook it up and hook the Hart 475 up to it and be able to calibrate that smart transmitter with the Hart transmitter. I'll give you more information on this later.